all that you would need to know in this class. That's why I was waiting for the tutorial question, because a good number of times the questions that will come out will be from the tutorial question. So, but based on what we have in first semester, few of the past questions actually also entails what you would have in the tutorial question. So this might probably be a guide for us on what to do. So it might be something that would help. So yeah. So what I'm trying to say is that even though you've attended this class and we've taken this past question together, it should not be all you will need to do for this course. You will still need to, by the time the tutorial question is out, check it out and try to practice the question. And at the end of this class, I'm going to try to drop the link to this video. I'm already recording it. So yeah. So let's just get straight into it. And I'm also hoping that we'll be able to get to the 6 questions before the end of this class, hopefully. So yeah, so the first question is identify if the system have a solution or not. So we want to know if we'll be able to solve this question, that is 1 and 2. That's question 1A, A high and AII. So let's go into it. We have x plus, I'm hoping we can see it. Okay, let me use the larger one. Okay, x plus 2y. Please, at any point I'm explaining, if you have any question, you can just drop it or unmute your mic to ask the question. Thank you. So we have this. So this is equation 1. This is equation 1. We have plus 4y plus 3z plus 4w equals to 5. We have that as equation 2. Then we have 5x plus 10y plus 8z plus 11w equals to 12. This is equation 3. Okay, in order to be able to solve this question, when you see this question, in order to be able to solve this question, the first thing you want to do is, for equation 1, you want to turn equation 1 to be something like this. X equals to, so it means you are making x the subject now. So that will now be 2. It means all these ones, you are carrying it over to the next end. So that will now be 2 minus, because you've carried this, so this will be 2 minus y plus 2z minus 3w. So this would now be our equation 4. This would be our equation 4. Now that we have equation 4 as this, what you would now do would now be that you would now substitute for x. This equation 4, you substitute x in both equation 2 and equation 3. So what I mean by that is, in equation 2 now, so substitute x in IV into II. Into II and then into III. So you are substituting for x in both, like in both 2 and 3. So to do that, we have so we'll have 2 into, our x now will now be 2 minus 2y plus 2z minus 3w plus 4y plus 3z plus 4w equals to 5. So this will now be 4 minus 4y plus 2z, plus 4z rather, plus 4z minus 6w plus 4y plus 3z plus 4w equals to 5. So when you subtract the normal ones, you would have, so you want to subtract 4y from minus 4y plus 4y. It means y is cancelled. So we would have 4z plus 3z. That would be plus 7. That would be plus 7z. Then um, minus 6w plus 4w. That would be minus 2w. Then equals to 5. Am I missing anything? This has cancelled this. 4y. Okay, I think I'm missing. Okay, minus 4y, minus 4y. This and this 7. This and this. Okay, minus 2. Yep. So this would now be 7z minus 2w equals to 1. So this will be equation 5. So this would be equation 5. Then we would now do the same thing. So maybe to further buttress this would be something like 7z equals to 1 plus 2w, more like. So so we are now going to substitute. We've done for equation 2, so we are also going to do for equation 3 too. Same thing. So this will be 5 into, when you are subbing x into it, it will be 2 minus 2y plus 2z, 2y, 2z, okay, minus 3w. Then plus 10y plus 8z plus 11w equals to 12. So this would be 10 minus 10y plus 10z minus 15w plus 10y plus 8z plus 11w equals to 12. So 10y cancelled 10 here too. So we have that cancelled. So we have z, this will be 18z, 18z minus 15, this will be minus 4, minus 4w. Then, okay, I did not start with 10, sorry. 10 minus, yep. So equals to 12. So this would be z. Yeah. So this would be 18z minus 4y equals to, if you take this over, that will be 2. That will be 2. I'm coming. I'm thinking. I'm guessing I've made a mistake. Sorry. 10 minus 10y plus 10 minus 15. Okay. I think. Okay. I know I've made a mistake. So this is not. This is supposed to be minus 8z from the question. It's minus 8z. So it means this is minus 8z. And this is also minus 8z. So that would mean 10z minus 8z would be 2, not 18. So this would be 2z. Wait, sorry. Yeah, this would be 2z. I'm sorry, I want to confirm. Okay, this would be plus 2z. Yes, plus 2z minus 4. Yep. So I think there is a mistake also in the first one. Sorry.
Yes, there's a mistake for the second equation. It's minus 3z, not plus 3z.
Minus 3z. Yeah, not plus 3z. Yeah. Please, anytime I make mistake, please call my attention to it. Thank you. Minus 3z. This is supposed to be 4. um, Z, yeah, Z plus minus 6, okay, minus 2W equals to 5. So this is supposed to be Z minus 2W here, then Z equals to 1 plus 2W. Yep. So, okay. 10 minus 2 minus 4, then this is going to be 2Z minus 4 minus 2. So if you divide through by 2, you would have Z minus 2W equals to 1. And that means Z equals to 1 plus 2W. For this particular equation, it has no solution. It is unsolvable. It is unsolvable because there is no way they both have like the same, we arrived at the same number. So, and what they want us to check for is to identify if the solution, if this system, like each particular system, if they have a solution or not. So for this one, we arrived at the same answer for both. So the answer would be that the system is inconsistent and therefore there's no solution. That is for 1I. Did we get that? Is there anyone with any question? Anyone confused before we move on? Anyone? Okay, so I'm guessing that we can move on. So for the B parts,
Sorry, I have a question.
okay.
Okay, let's go back to the upside. That substitution.
Okay, for the
Repeating.
substitution. So okay, let me just
Yeah,
rephrase.
to understand
Let me
that.
rephrase. Let me
Yeah.
let me rephrase again. So you have this question, right? So the first thing you will do is for the first equation, you turn x, like you make x the, I think, subject. You make x the subject. Yeah. So by that, that means you move everything that you have here. You move everything you have here. You move them to the other side so that x becomes like the subject. So that is why we now have this equation 4, right? So from this equation 4, we are going to plug in x into equation 2. That means we have we have 2x here. What's that? Is that a notification? Okay, you have a question. If you have a question, unmute your mic, please. If you have a question, just unmute your mic. Please,
Sorry, it's
but
not a question per se, but I'm not seeing. Are you sharing your screen? I'm
yes,
not seeing anything. I'm just
I'm
hearing.
sharing. Yes, I'm
I'm
sharing
just
my
hearing.
screen. Is there anyone that cannot see
Oh,
my
well,
screen? Probably you try to log out and log in again. Try to log
okay,
out
I'll do
and log
just
in.
that. Thank
Yeah.
you. All
Okay.
right, thank you.
So yeah, so you substitute for x here in this equation. So you have 2. This is what you have in x, the equation 4 that you formed. So you substitute it here, plus 4y minus 3z plus 4, like this whole equation in 2. And then you arrive at this. You arrive at 5. The same thing you do for equation 3. You do the same thing for equation 3. Assuming the equation is solvable, you'd have had something different that would make it easier for you to plug z, or maybe be able to get a w here. That will make you to easily plug this equation, this new equation you get, into the formula to get a solution. But as it stands, this particular um, question is unsolvable. It does not have a solution, rather. So did you get that? Can we move on?
Yes, we can. Thank you.
Okay. Okay. So for the B part, we have 2x minus 3y plus 6z plus 2v minus 5w equals to 3. That is equation 1. equation 2, we have y minus 4z plus v equals to 1. That's equation 2. Then for 3, we have v. We have v minus 3w equals to 2. So for this particular one, yeah, so I'm just going to follow. I'm going to follow the instruction from the notes. I'm going to follow the instruction from the notes because I really did not understand this particular one. But based on what is in the notes, we are told that we are going to choose um, free value. We are going to choose free value for Z and W. We are going to choose free value for, so choose free value for Z and W. And so the free value that was chosen is Z equals to, if Z equals to 1, then W equals to minus 1. So we are going to now plug this into our equation. So plugging this into our equation would now be, since W equals to minus 1, that would mean that equation 3 would be equals to V minus 3 into minus 1 equals to minus 1. And that will give us V plus 3, minus 3 times minus 1 will be plus 3 equals to minus 1. So that means V would be equals to minus 4 because you carry 3 here to this place. That would be minus 1 minus 3, which would be equals to minus 4. So now we know Z, we know W, and we know V. So in order to get the other ones, we are just going to plug in what we have. So for equation 2, we would plug in, so our y will now be equals to y minus 4z. Remember our z is 1 plus v. Our v is now minus 4, so that will be minus 4. This equation, y minus 4z plus v, which is now minus 4, equals to 1. And this would give us minus 4 minus 4, that would be minus 8, equals to 1. It means our y would be equals to 9 because 8 will move to the other hand. So that would mean our y would be equals to wait, I'm coming. Minus 3. I made a mistake. I made a mistake. This would be wait. No. Plus 3. V2. Okay. The mistake I made is in writing 1 here. This should be 2. I'm sorry. This is V minus 3, W equals to 2. V minus 3 equals to 2, not minus 1. So this is supposed to be, when you bring minus, this will be 3. When you bring 3 to the other side, that would be minus 3. So that would be minus 1, because that would be 2 minus 3. That would be minus 1, not 4. Okay, so this would be minus 4 minus, this would be minus 1, right? Y plus, yeah, minus 1. Sorry, I need to plug my laptop. Minus 1, so that would be minus 4 minus 4 minus 1, that would be minus 5. This would be minus 5. So if you move this to the other side, this would be 6. This will be 6, not 9. So now we have V, we have Y, we have Z and W. We are now going to plug this into the full main equation, which is now 2x, 2x, we don't know x yet, minus 3, we know y, which is 6, minus 6, plus 6z, z is 1, then plus 2v, v is minus 1, then minus 5w, w is minus 1, equals to 3. So that will be 2x minus 12, minus 18, minus 3 times 6, that's minus 18, plus 6, minus 2, plus 5, plus 5, equals to 3. So this would be 2x, this is minus 12, minus 12 minus 2, that's minus 14, minus 14 plus 5, that is minus 9. So that would be minus 9 equals to 3. Let me just check to see. Yes. So we have 2x minus 9 equals to 3. So that will be 2x equals to 9 to the other side will give us 12. It means x will be equals to 6. So it means our answer would be x equals to 6, y equals to 6, z, w, x, y, z. W equals to minus 1, x, y, then z equals to 1. So this is the answer for this. Any question? Any question?
Yes, I have a question.
Okay.
So are we just to assume that Z and W, are we just to assume any values to them? Why did we
I,
not solve it the way we solved the first question?
I think if
Why
we
did we
try,
just assume
so if we
values?
try to solve it the way I think the reason, I don't know, but I'm guessing the reason why we have a free value here is because, for example, if we try to use y here now, like let's say, if we try to use like solving equation 1 here, we will not be able to have an answer except we do something like, say, v equals to 2 plus 3w, and we plug where we have v, we plug it here, and then probably we do the same thing. We do the same thing here, I'm guessing, but I don't know. I really don't know. I still have not gotten the idea behind why we use the free value. Like I said, this was what I saw in the notes directly for this particular one. It was from the notes, and this was where it was solved. This was how it was solved rather. So I'm guessing that that is how we are going to solve it for this particular one.
Okay, thank you. Thank you.
Yes. So is there any other question before we move to the next one? Any other question? So before we move to the next one, in the notes, there is also another equation. There's another equation question, but this is from the notes, right? So I'm guessing that it can be what will come out, might not be this past question. So we have like we have an equation x2y plus x2y minus 3z equals to 4 as equation 1. Then we have x plus 3y plus z equals to 11. Then we have 2x plus 5y. Trying to see, is this plus 5y? Sorry, I want to confirm if, okay, I think this is 3y, not 3y minus 4z equals to 13. Then 2x plus 6y plus 2z equals to 22. So the same way we did the first one, we are going to turn in equation 1, we make x, so that will be 4. X equals to 4 minus 2y plus 3z. Yeah, 4 minus 2y plus 3z. Yep. So that will now be equation, this is 1, 2, 3, 4. So that will now be equation 5. That will be equation 5 in this case. And then, so we'll now plug in 5 into the other ones. So that means for our x here, this will just be 4 minus 2y plus 3z plus 3y plus z equals to 11. Yep. And then we would have, with this, we are going to have minus 2y. So we have y, 3z plus, that would be 4z, yep, equals to 11 minus 4, which is 11 minus 4 is 7, which is equals to 7. Yep. So this would be equation 6. So we do the same thing to equation 1, 2, 3, equation 3. So that will be 2 into 4 minus 2y plus 3z. Yep. Plus, coming. Yeah, okay, this is 5. I've seen it clearly now. This is 5, not 3. So plus 5y minus 4z equals to 13. So this would be 8 minus 4y plus 6z plus 5y minus 4z equals to 13. So this would be y like minus 4y plus 5, that's y, plus 6z, this would be plus 2y, I mean plus 2z, yep, plus 2z equals to 13 minus 8, that's 5. 13 minus 8 is 5. So this is now equation, right? Yes, 2z, okay. This is equation 6, 7, that will be 7. Yep. Then we'll plug it into the third one, into the fourth one. So the fourth one is 2 into 4 minus 2y plus 3z plus 6y plus 2z equals to 22. So 8 minus 4y plus 6z plus 6y plus 2z equals to 22. So this would be 2y plus 8z equals to 22 minus 8 is that 14? No. 22 minus 8, 14. So that's 14. So if you divide through by 2, you would have y plus 4z equals to 7. Yeah, we have the same thing here. So now, to now solve this, so we are now going to now solve equation. We are now going to solve this equation. We are going to solve equation 1. Equation 1, equation 1, 6, 7, and 8. Equation 1, 6, 7, and 8. So first off, we can subtract equation 6 and 7. 6 and 7. What I mean by that is that we would have something like this: y plus 4z equals to 7, y plus 2z equals to 5. So if you run this calculation, minus here would cancel this. So that will now be 4z minus 2z, which would now give us 2z equals to 2. So that would now mean z equals to 1. Yep. So z equals to 1. So now that we know that z equals to 1, we can plug it here into y plus 4, since z is 1. y plus 4 is 4, like z is 1, so 4 times 1 is 1 equals to 7. So it means y would be equals to 3, right? Y equals to 3. So we know z, we know y, so we can now plug it into any of the equations. So let's plug it into equation 6 to get z. I mean, into equation 5 so that we can get x, rather. Into equation 5 so that we get x. So equation 5 is, I'm just going to copy this. So this is equation 5. So x would be equals to 4 minus 2y, that would be 6. 2 times 3, that would be 6. Plus z is 1, so that would be plus 3. So it means our x would now be 4 minus 6 is minus 2. Minus 2 plus 3, that's 1. It means x equals to 1. So it means x equals to 1, y equals to 3, z equals to 1. And that is the, yep, that is the answer, 131. So I think with this second example, we probably know how to solve questions like this. Are we okay here? Are we good here? Anybody with question? Anybody? Anyone with question? So I'm guessing there's nobody with question. We are good there, right? So now let's go to question 1B. Let me move this guy. Okay. Question 1B. Okay. For question 1B, we are told to consider vector space alpha. I don't have alpha. Let me see. Search library. Sorry. Let me just use something to represent alpha. So let's take alpha as A. So we have A equals to A equals to, sorry, permit me to move this closer. Okay. A equals to 2, 0, 1, then comma 1, 1, 0, then comma 1, 1, 1, then yeah, then we have beta as equals to minus 1, comma minus 3, comma minus 2, then comma 7, 7, 5, then comma 4, 4, 4. So now they want us to determine delta underscore alpha. So they want us to determine beta underscore alpha. To be able to solve this question, right, what we are going to do is we are going to use we are going to use the beta. We are going to solve it. We are going to solve the equation alpha now using each of the beta condition, like each of these one, like each of these, this, and this. So since beta alpha would mean that we have something like this. Beta alpha would mean that we have something like this minus, let me just copy instead of rewriting. It will mean that we have something like this alpha, then then this alpha, then the third one. Since what they want us to solve is now, what they want us to solve is beta underscore alpha. That's what they want us to determine. So the first thing we are going to do is we are going to turn, so the alpha would now be, our alpha representation would be something like this. This is what our alpha representation would look like. Our alpha representation would be x, x1, but okay, let me use, is there a subscript? Okay, let me use XYZ in this case. Normally, I'm supposed to use X1, X2, X3. Okay, so we have X plus Y into the second one. Then plus Z into the third one. Okay, so this is alpha equals to. So when we now want to solve this, we will solve for this first one. We'll solve for this first one, solve for this second one, solve for this third one. So what I mean by that is that we are now going to turn this into an equation. And by turning it into an equation, it is going to mean that this is, we're going to take this as, sorry, normally in normal whatever, this is going to be x1, x2, x3, x1, x2, x3, x1, x2, x3. Sorry. So that would now mean that this would give us 2. In this case, we are using XYZ. So that would mean this would give us 2x plus y. Since this is 1, what we have here is 1 plus y plus what we have here is also 1 plus z equals to, we are solving for this first. We are using this first. So in using this, it means that the solution for the first one here would be -1. So this is equation 1. Then the second one, so same way, this is going to be 0. So our x here will be 0. Then this will be plus y, then plus z equals to -3. This is equation 2. Then for the third one, we have x plus y is 0, so we don't have any representation for y. So that will be plus z equals to -2. So this is equation 3. So we are going to solve for this. So when we are done with solving for this, we'll do the same thing when this would be what we would have here. So instead of what we have here, it will now be 775. We'll solve for these two. Then we would also solve for these two, getting the answer, getting our x, y, z in each one. So now let's go. Did we get it to this place, please? Did we get it to this place before we continue? Did we get it to this place?
Yes.
Okay.
Yes.
Okay. If we don't get it, you can probably just rewatch by the time I upload and sit down a bit calmer to get it. So now we want to solve this equation. To solve this equation, I think the easiest one would be using equation 2, or we can also use equation 3. We can use any of these two equations and then plug the resultant into the other one. But in this case, I want to use equation 2. So so this will be y equals to -3 minus z, right? So that will be equation 4. So now that I have my y, as that, I can also do for x2 here, for x in equation 3. So x equals to -2 minus z. So that is equation 5. So since I know my x and I know my y here, I will now plug this into equation 1 in order to be able to get uh, my x. Yes, in order to be able to get my x. So that would now be 2x plus, remembering that y is now this, so that will be minus 3 minus 3 minus z plus z. Okay, sorry, x and y. What I'm looking for is z. Okay, x and y. So that will be 2 into x is minus 2 minus z plus y is minus 3 minus z plus z equals to minus 1. So this would give us minus 4 minus 2z minus 3 minus x minus z cancels, minus z plus z, that is 0. So this cancels already, equals to minus 1. So this will give us minus 2z equals to minus 1 minus 3 minus 4 minus 3, that's minus 7. If we carry it to the other side, that will be plus 7. So that will be plus 7. So this would be minus 2z equals to 6. So z equals to minus 3. Z equals to minus 3. Now we can now plug z into both y and x, into our equation 4 and equation 5 to get. So it means plugging it into equation 4, we have y equals to minus 3 minus z, that is minus into minus 3, that will be plus 3. Yep, that will be plus 3, which will give us 0. It means our y is 0. For x equals to minus 2 into minus 2 minus z is minus 3 into minus 3. It means that x would be equals to minus 2 plus 3, which means x equals to 1. So it means in this case, x equals to 1, comma, y equals to 0, comma, z equals to minus 3. Equals to minus 3. So that's the first one. Did we get this? Did we get this, please?
Yes.
Okay. So we've done for when this. So now we are now going to do for the other one. We are going to do for this. So we are copying the same formula, duplicate this one now, but for this. So it means this will now be minus 7 again. This will be 7, this will be 7, and then this will be 5. So now it means our equation 4 will now be y equals to 7 minus z. That's equation 4. And then equation 5 would be x equals to 5 minus z. That's equation 5. Then that's what we are now going to plug into equation 1. That will be 2 into 7 minus z minus, y. What am I doing? X first. 5 minus z plus 7 minus z, then plus z equals to 7. Remembering this is what we are solving, right? So this will now give us, 10 minus 2z plus 7. This cancels out, equals to 7. So this would be, by the time you move this to the other side, so it also cancels it out. So this would be 10 minus 2z equals to 0. So it means you can move either of them. So that will be 2z equals to 10, z equals to 5. The reason I change this is because if I move this here, this will become plus. So if I move this here, this will become minus. So the minus will cancel each other. So z is 5. So that means that x will be equals to 5 minus 5, which equals to 0. And y will be equals to 7 minus 5, which equals to 2. So it means in this case, x equals 0, y equals 2, z equals 5. So that's the second one. Then we do, oh, sorry. Please give me a few minutes. I need to bring my fan here. I'm sorry. Sorry. Yeah. Okay, so for the third one, we are doing the same thing. But in this case, for 444, so we are replacing this, what we have here, 4, 4, and 4. So that means our y equals to equals to 4 minus z, and our x equals to 4 minus z. So, yep. So we are plugging it into the main equation. 4 minus z plus 4 minus z plus z equals to 4. This is 8 minus 2z plus 4 equals to 4. So this becomes 0. So it means 8 minus 2z equals to 0. So it means 2z equals to 8, z equals to 4. Yep, z equals to 4. So it means our x would be equals to 4 minus 4, which is 0. X would be equals to 0. Y would also be 4 minus 4. Y equals to 0. Yes. So that means we have x equals to 0, y equals to 0, z equals to 4. Yep. So our beta alpha will now be, so we are now going to turn this into a, what's it called now? Is it a matrix now? Yeah. So that would now give us 1, 0, minus 3. Then the second one is 0, 2, 5. And the third one is 0, 0, 4. And yeah, that is, so this is our answer. This is the answer for this equation for 1b. For 1b. Did we get this? Did we get this? Is this clear?
Yes, it is.
Okay. So Okay, we spent an hour. Okay, question 2. Question 2 says that we should verify this matrix in Cayley-Hamilton's theorem. I think for those of us that did first semester, I'm not sure, was this question in our, is it in our tutorial question, or it was actually a question, it was actually a question that we were to answer. I can't remember. Bisoye, did we answer this particular question? Did we do this particular question in the
Yes.
exam?
No, we did not. It was just in the tutorial question, but
Tutorial
it didn't come out.
question. Yeah,
Yeah.
okay. 1, then 4, then 2, then 3. So we're told to verify for Cayley-Hamilton's theorem. So for Cayley-Hamilton's theorem, it says that A alpha, we don't have an alpha here. What do I do? What do I do? No, but this is alpha. This is, I can't even remember. But anyways, okay. It says that for this would be equals to this A minus A minus this sorry. Okay. A minus this I. Yep. So this is Cayley-Hamilton's theorem, and we are going to solve this. This is what we want to solve. So to solve this, this would be a matrix A, what we have as A, that is what we have here, which is 1. Okay, just permit me. This is supposed to be in brackets. 1, 4, then 2, 3, minus this sign. Let me use this y to represent it into I is 1 0 1 0 0 1. This is supposed to be in brackets, so let me just put this brackets then yep. So this is what we are going to, this is what we want to solve. So that means this would give us 1 minus alpha, because by the time you multiply this, this will take is it alpha or gamma self? What's this sign? What's this sign rather? Can anyone remember what this sign is in math? Lambda. Yes, thank you. Yeah, thank you. So if you multiply this, this would be lambda 0, 0 lambda. Yes, thank you. So we would now have something like this. This would be lambda 0, 0 lambda. So this would be 1 minus, this would be 1 minus lambda, 1 minus lambda 4, then 2, 3 minus lambda. Yep, so this is what we are going to have. And we are going to solve this multiplied by this minus this. Did we get this so far, please? Did you get that?
No,
How we come by this? Okay, so let me.
no.
Okay, I'm going to explain.
Is it not going to carry the signs, maybe the negative? I think.
No. That's what I want to do now. So this would be minus, right? Minus, this would be y. This would be y. I mean lambda. Lambda 0, 0, 0 lambda, right? So with this, what we have here, this is it. So now in order to do this, remember this is the way multiplication of matrices works is this, what you have at this top, this times this, right? This times this. So what you have is 1 times minus lambda, that is what we have here, then plus 4 times 0, that's 0. So it means the only thing we have here is minus lambda. Did we get that? Did we get this? Did we get that? Did we get that? Did we get that?
I understand it. I don't know if anyone has questions, sir.
No, I think the people that are having questions are probably people that have not done that did not do the matrices last the last class. I mean last semester. But this is what we are going to have. This is what we are going to have. I'm trying to, because we still have a lot of questions, so I'm trying to at least rush up a bit. I'm trying to rush up a bit. So we are going to multiply 1 minus lambda dot 3 minus lambda minus 2 times 4. That will be 8. That will be minus 8. Minus 8, yes. That will be minus 8. So in solving this, 1 times 3 would be 3 minus lambda minus 3 lambda plus lambda square. Lambda raised to power. Let me just use this. This is raised to power. I'm using this as, okay, let me use, yeah, raised to power. This is lambda square minus 8, right? So we would now have lambda square minus 4 lambda minus 5. Minus 4 lambda minus 5. So that is what we have. This is the equation that we would have. Did we get it up to this point, please? Did we get it up to this point?
Yes.
Okay, thank you. It will be better if there's a lambda. So when you are writing this, don't write y. Make sure you are writing lambda, please. So that is because I cannot get the actual sign. That is why I'm improvising that, because that's very, very important. So by Cayley-Hamilton's theorem, theorem, what we would now have would be, this would now be a raised to power 2 minus 4a minus 5 equals to 0. So in order to verify Cayley-Hamilton's theorem, by the time you do this, can't remember the name they call this. But by the time you do this, where A lambda equals to the matrix of A minus lambda high, and you solve this, by the time you do this, you are going to have lambda square minus 4y minus 5. So you are now going to make this A raised to power 2 minus 4a minus 5 equals to 0. So what you are now going to do, you are now going to substitute A here. That would now be our A, the matrix that we have here, the A matrix we have here. So that would mean that this would be, this is 1 4 2 3, right? So we have 1 4 2 3 close brackets, then same thing that we have here. So since it is, why is it not copying the rest? So since it is what's it called now? Okay. So no, 3. Yep. So this a square, this is a square. There will be a dot here. That's it. You are multiplying this matrix by this matrix, then minus 4 into this matrix again. Trying to represent all of this is it's becoming a struggle. Okay, minus, let me just write it. Let me write it. Okay. One, 4, 2, 3, then minus 5 will be equals to 0. So this is what you are going to have. By the time you solve all of this, the matrix we will end up having would be a 0 matrix. And that would confirm Cayley-Hamilton's theorem. So quick one, let's do this. So what we want to do is we are multiplying this by this for each one, then like that, like that. So let's start. Let's start. 1 times 1, that will be 1 plus 1 times 1 plus 4 times 2, that is 8. Then 1 times 4, 1 times 4, 4 plus 4 times 3, 12. This is from normal matrix calculation. So if you don't get this, probably you have to move back a bit to matrix calculation, to understanding matrix calculation. Yep. So the next one, 2 times 1 is 2 plus 3 times 2, which is 6. Then 2 times 4. 2 times 4 is 8. Then plus 3 times 3, which is 9. Then we would now have a minus 4. So minus 4 here would be minus 4. Minus 4. It's still going to be minus. So minus 4 times 1 is 4. 4 times 4 is going to be 4 times 4 is going to be 16. Then 4 times 2 would be 8. 4 times 3 would be 12. Then minus 5. Right? So minus 5 is minus 5 is going to be 5 into, I did not write this. This is supposed to be 5 into 1 let me write it here instead. Permit me, please. 1 0 0 1, because it's a matrix. So this is 5. This is 5 in matrix. So that means by the time we are multiplying this is going to give us this is going to give us 5 times 5, that's 25. This is going to give us minus 5. This is going to give us 5 0 0 5. I'm sorry. So yeah, this would now be okay. So instead of 5 being here, we would have 5 5. Yes. So this is the representation of 5 in matrix form. Yep. So equals, remember that all of this is equals to 0. This is same as 0 0 0. 0 0 0 0. Okay. So now what we will have here would now be 9. 4 plus 2, 4 plus 12 is 16. 4 plus 12 is 16. 2 plus 6 is 8. This is 17, right? Yes. 17. Then minus 4, 16, 8, 12, minus 5, 0, 0, 5. Remember, each one of these it's a matrix, so that we don't forget that. So now 9 minus 4, that is 5. 5 minus 5, that's 0. 0. That's this first side. Because it's subtraction, so you do it as normal subtraction. 9 minus 4 minus 5, that's 0. 16 minus 16, 0. 0 minus 0, that's 0. 8 minus 8, 0 minus 0, that's 0. 17 minus 12, 5. 5 minus 5, 0. So 0 equals to 0. So therefore, this particular, what's it called now? This particular matrix A, it fulfills Cagliani's theorem. That's what we are looking for. So this particular matrix fulfills Cagliani's theorem. Are we good here? Any question?
I don't have question.
Does anyone have a question? Anybody with question, please? If you have question, please unmute your mic. Okay, if there is none, let's go. Let me see. This is 8:14. I'm not sure we'll be able to take all the questions. I'm guessing, I don't know if we would need to do the remaining one, but I don't know. Maybe we would have to complete the remaining tomorrow evening. But I'll try to see if we can do up to question 3, like we finish question 3. So 2b says that let A equals to okay. 2b says let A equals to 3, 4, 2, 1. Just permit me to write it like this. I think it's stressing me trying to put all those things in it. So it says that let A equals to this. Then we have to find the eigenvalue, and then find the eigenvalue of A, then the associated eigenvector. Yeah. So find the eigenvalue of A, then the associated eigenvector. So to solve this, this is going to be okay. This is going to be A AV. You are going to represent it with V. AV minus lambda. When you see this Y, please know that it is lambda. Lambda IV equals to 0. So our V here is the same thing as V1, V2, as in by V1, V2, I mean this. Yeah, that is what our V is. So that is what our V is. So it means now our A would now be, so it means it is now going to be A V1, V2. Oh my God. A V1, V2 minus lambda into I. Remember that I is 1, 0, 0, 1. Okay, 1, 0, 0, 1. Then V1, V2. V1, V2 equals to 0. So represents the 0 matrix, equals to 0, 0. So now we are going to solve this. So since both so this is okay. So now we'll now bring our A. Remember our A is 3, 4, 2, 1. Our A is 3, 4, 2, 1. So we have 3, 4, 2, 1. 3, 4, 2, 1 minus this is going to be lambda 0. 3, 4, 2, 1. This V1 is still there. V1, V1, V2. Then minus lambda 0, 0 lambda. V1, oh no, V1, V2 equals to 0. So if we do this multiplication, if we do this calculation, we are going to have something like this. We are going to have 3 minus, just like we had the other time, 3 minus lambda 4, 2, 1 minus lambda. So just like the kind of equation we had the other time. So we are going to have something like that. Then, yep. Then V1, V2 equals to 0. So we have something like this. Let me put the brackets so that yep. So this is what we are going to have equals to 0. So in order to now get our answer, we are going to solve this first, what we have inside here only first. So this would give us 3 lambda. So that will be 3 minus lambda into 1 minus lambda, then minus 8 equals to 0. So that will be 3 minus 3 lambda minus 4, minus lambda plus lambda square equals to 0. So that will be 3 minus 4 lambda plus lambda square equals to 0. So the way you minus 4 lambda plus 3 equals to 0 plus 3 equals to 0. So the way you solve normal quadratic equation when you are finding, I think I've missed something.
You've thrown away the 8 too. Minus
Yeah.
8, that is what?
Yeah. That's minus 8. I know that I missed something. So if there's minus 8 here, it means that this is going to be minus 5. It's going to be minus 5. So yeah, so we have something like this. So in solving quadratic equation, so that would be minus 5 plus 1. Yes, minus 5 plus 1. Minus 5 would give us minus 5. Minus 5 plus 1 would give us minus 4. So what we would now have would be lambda minus 5 into lambda plus 1. I'm guessing every one of us knows how we got here, like quadratic equation. I'm very sorry for those that probably did not do maths, and this is their first semester. I'm sorry, but maybe you try to research it so that you know how we got this. So using this would mean that our lambda would be equals to 5 or lambda equals to minus 1. So now that we've gotten lambda equals to 5 or minus 1, our job is not done. So our eigenvalue is equals to 5 and minus 1. This is our eigenvalue. So remember that it's two things we are looking for. We are looking for the eigenvalue of A, then the associative eigenvector. So now to get the eigenvector, now we'll now go back to this. Now we'll now plug for when lambda equals to 5. So when lambda equals to 5, so we'll plug it into this. So when lambda equals to 5, we would have 3 minus 5, 4 plus 2, 1 minus 5. Then we still have our V1 and V2 equals to 0, right? Remember, this is like this. So yep. So this is going to give us minus 2, 4, 2, minus 4, V1, V2 equals to 0. So when you multiply this is going to be minus 2 V1 minus 2v1 plus 4v2 equals to 0. That is equation 1. Then for the second one, 2v1 minus 4v2 equals to 0. So to solve this now, we now have what do we have? We have 2v1 equals to 4v2. So it means v1 equals to 2v2. Yeah, v1 equals to 2v2. So that is when lambda equals to 5. So that's when lambda equals to 5. So in this case, if we assume that our v2 equals to 1, then it means our v1 would be equals to 2. If we assume, we are going to use an assumption here, because both formulas, they come out as the same thing. Because if you also do this too, you would, if you do the other one, let me see, this other one will be minus 2v1 equals to minus 4v2, and then you come across the same answer too. So if you assume that, so we are going to make an assumption that v1 equals to v2 equals to 1. So if v2 equals to 1, our v1 will be equals to 2, because v1 equals to, so this one will be 1. All right, whatever, sorry. So, yep, so if our v2 equals to 1, our v1 will be equals to 2. That's for when lambda equals to 5. So we are going to do the same thing for when lambda equals to minus 1. So for when lambda equals to minus 1, we are going to have 3 minus 1 for 2 into 1 minus 1. Then same thing, we have v1, v2, we have 0 for both of them. So in calculating this would be 3 minus 1, that's 3, that's 4, because 4 for 2 minus 1. No, this should be, okay. This is supposed to be minus 1, yeah. So 2. Then we have v1, v2. And from this now, we will now have this equation 4v1 plus 4v2 equals to 0. Then the second one, 2v1 plus 2v2 equals to 0. Yep. So from this equation, from both equations, right? From both equations, we arrive at v1 equals to v2, because by the time we move this to the other side, right? Okay, v1 equals to minus v2 rather. By the time we move this equation to the other side, like you move this is now going to become 4v1 equals to minus 4v2, and then you divide by 4, so you have v1 equals to minus 4v2. Same thing if you do also here too. So if you assume, so we have to assume that our v1 here is 1. So if our v1 is 1, anyone that will make 1, it means it's going to be the inverse of the other one. So if we assume that v1 equals 1, so our v2 would now be equals to minus 1. No, if we assume our v2 rather, sorry, if we assume our v2 to be equals to 1, then our v1 would be minus 1. Yeah, minus 1. I know the question would be, why are we assuming? The reason we are assuming is because of both formulas, like both equation, they have the same. There's no way we want to subtract from each other, so we'll just have to use an assumption to get a solution for this. And I think this is also, yeah, I think I saw it in a particular textbook or something. But anyways, so this is now going to be, so this is going to be the eigenvector. Yes, this is going to be the eigenvector that we would have. So we'll have v1 here 2, v2 here 1, then this one would be for each situation. So that is that's question 2b, right? That's question 2b. So for question 3, divine equivalence and similarity of matrix, I think we can check that online to get the answer, so that we don't waste our time. We just move to the next one. So let's move to the next one, which is the B, which is the inverse of matrix. Inverse of matrix. Okay. So inverse of matrix. So inverse of matrix. We want to find the inverse of matrix. 3 minus 2. I think this is this our exam question? I think it's our exam. It's either exam question or tutorial question in first semester, because I checked the question in first semester. Yep. So minus 1, 5, 2. So to find the inverse, we want to find B inverse, right? So we want to find B inverse. B raised to power minus 1. So that's what we want to find. So to find B inverse is the same thing as 1 over B, 1 over determinant of B. Oh, I don't know how to, okay. 1 over determinant of B. Yep. Into the adjoint of B. Yep. So our B inverse is 1 over determinant of B into adjoint of B. So the first thing, we want to find the determinant of B. I want to find the determinant of B. That's the first thing we want to do. So to find the determinant of B, it's going to be a long ride. To find the determinant of B, we would do our normal matrix equation. So that would be 3 into for the first one. So it means we would have 3 into so we have 3 into 1, 3, 5, 2, then the second one should be a minus. So that would be minus 2, minus 2. That's plus. Minus 2, same thing. But in this case, it is now going to be this now for this one. So that will be 4 3 minus 1 2. Then the third one, for the third one will be plus 1 into so for the third one it will be 4, 1 minus 1, 5. So that is so this is to get our, what's it called now, to get our determinant. So this will be 3 into 1 times 2, that's 2, minus 3 times 5, that's 15. Close brackets. This is plus 2 into 4 times 2. Sorry, 4 times 2 is 8. 3 minus, that will be 8 minus 3 times minus 1, that will be minus 3. Then plus 1 into 4 times 5 is 20 minus 1 times minus 1, that's minus 1. Minus 1, close brackets. So this is 3 into 30, minus 13, right? 3 into minus 13 plus 2 into 8. This is 8 plus 3, that's 11. Then plus 1 into 20 plus 1, because minus 1 here, that's 21. So we would have 3 times minus 13, that is minus 39, plus 22 plus 21. So this is minus 39 plus 43, which is equals to 5. Which is equals to 4 rather. 9 and 34, which is equals to 4. So it means our B determinant equals to 4. Right? So we've solved the first part. So for this second part, we are now going to pick the equation. Like now we want to find the adjoints. Now to find the adjoints, what we will do is we are just going to do similar thing as we did here, but in this particular case, we will not be needing the multiplier we have outside. So what we'll be multiplying would be just this. So just following the rule of plus minus plus, then minus plus minus, then plus minus plus again. So that's the rule we are going to follow. So based on that now, for the first one, we already have the first one. This is the first one. This is the first one. Okay, let me just rewrite it. The first one would be 1, 3, 5, 2 minus 4, 3 minus 1, 2, then 4, 1 minus 1, 5. So this is the first one. So this is plus, please. So in calculating this, we would have for this would be 2 minus, this is going to be 2 minus 15, right? That's what we have in this particular matrix zone. This one will be minus 8 rather. Minus 8 into minus 1. So this would be plus this is actually minus, but it's going to be plus 3, plus 3, yes. Then plus 4 times 5, that is 20, plus 1. So that is what we are going to have. This is the first. So this is going to be a matrix. This is going to be what our final matrix would be. What we want to do is to turn this into a final matrix. So it means this is minus 13. This is minus 11. And then this is 21. So we'll do the same thing. The second line. For the second line now, let me just do, okay. For the second line, what we would have in the second line would be, so second line is going to be something like this. So second line would be crossing this and this for the first one. So our first value is minus 2, 1, 5, 2. But remember that this is minus plus minus, so it means this would have outside of this would have a minus. Yep. Okay. So we have this, then plus. So for the next one, this will be here. So we will have plus 3, 1, minus 1, 2. So that's the second one. Then for the third one, we will have minus 3, minus 2, minus 1, 5. So we would have this. Okay, so for this matrix now, this would now be equals to minus into minus 2 times 4, that would be minus 4 minus 5, minus 4 minus 5 plus 3 times 2, that is 6, minus 1, that's minus 1 plus minus 1, so this one will be plus 1. Then minus 3 times 5, that's 15, minus 1 times minus 2, that is minus 2, minus 2, that is plus 2. I mean, minus 1 times minus 2, that's plus 2 right there. So that would be minus 2 instead. So it means this would now give us minus 4 minus 5, that's minus 9. Minus 9 times minus, this would give us 9. 9, this would give us 7. And then this will give us minus 13. Then we do the third one too. So for the third one,
Sorry, there is mistake with the first one.
with the first
It should
one,
be minus 5. Yeah, it should be minus 5, no minus 11.
let me see.
It should be minus 8 minus 3.
This one,
Yes.
4 times this,
Then
8, yes. So minus
yeah.
1, there's a minus here. Minus 1 times 3, that's minus 3. There's a minus, minus 3.
You're right, sorry.
Yeah. So 9, 7, minus 13. So the third one, so for the third one, we'll have something like this. And then again, So this will be plus minus plus. We would have minus 2, 1, 1, 3 minus into, so second phase will be minus into 3, 1, 3, 1, 4, 3. Then the third part, we'll move this to this. Then the third part would be 3 minus 2 into, we have 4 and 1. So, yep. So this is a plus here. There's a plus here. Okay. So now this would give us minus 6 minus 1. Yep. Then minus into 3 times 3, 9 minus 4. Then plus into 3, 4 times 2, that's 8 minus 8. That is plus 8. Plus 8. So this would give us minus 7, 5 minus 5, and then 11. So it is now this answer we will now use to form a matrix. We'll now use to form this matrix that we have here. So we have minus 13, minus 11, right? Then 21, then 9, 7, minus 13, minus 7, minus 5, 11. So our answer would now be, our final answer will now be equals to, it will be equals to 1 over, remember our adjunct is 5, right? 1 over 5. Now, when we now want to write this our matrix now, we'll now turn rows into column. Each of these row would become a column. What I mean by that is this will now be written as, so this would be the rows now. So this will now be minus 13, 9, 7, minus 11, 7, 5, minus 7, 21, yep, minus 13, 11. So this is the expected answer. So this is the inverse of, it's not 5, it is 4, sorry. So this is the inverse of B. Yeah, do you have any question? Do you have any question? I'm afraid, so we'll have to stop here this evening. Tomorrow, same time, because it's already 2 hours, So tomorrow, same time, I'm hoping that we'll be able to cover all the remaining ones tomorrow. So tomorrow by, I don't know if we should shift it forward. Should we make it 6 or 5? If it is convenient, it's something I can start by 5. If it's convenient for us, but I just feel that the evening time is much more convenient for everybody. What's the consensus, please?
I don't know if, whatever time is okay for me. I don't know for others.
Same time we did it today is okay.
Okay. So let's just start by we start by 7, right? So let's start by 7 again tomorrow by 7, so that we are going to complete the remaining ones. And please, let's just make sure that we'll go through the notes too, because I think for test question is basically going to be around what we already have in the notes. And I think from what I can see from the notes, I'm not sure we've gone past um, question one only, like things around question one. So you most likely have questions like this. So I think there are questions in the notes that don't have answers. You can probably just pick equations like this and then just try to solve them out. So I will